Next, I want to show how we can use rejection regions instead of p-values to solve the same problem. And you'll notice that many of the steps are the same. So step 1 is verify that either the population is normally distributed or the sample size is greater than or equal to 30. Step 2 is state the claim. Step 3, state the null hypothesis and the alternative hypothesis. Step 4, determine if the test is left-tailed, right-tailed, or two-tailed. Next, we need to identify all of the information that we had to before. But now, we also need to identify the critical value z0. And to do that, we need to refer to this table. On step 6, we calculate z. Step 7, graph z0, the rejection region, and z. Step 8 is the decision, so we want to compare the standardized test statistic z with the rejection region. And if z is in the rejection region, then we reject the null hypothesis. If z is not in the rejection region, then we fail to reject the null hypothesis. And step 9, we have to write the correct conclusion. Because question 2 is identical to question 1, I've already filled in all of the steps that are the same as the p-value method. So the next steps are unique to the rejection region method. So first we have to look up z0 on the critical value table, and that's equal to negative 1.28. Next, we can graph the rejection region, so it's the area to the left of negative 1.28. And then graph z, so that would be right there. So z is in the rejection region, which means we want to reject the null hypothesis. So we get the exact same conclusion that we did on question number 1. So it doesn't matter which method you use.